Hello, I'm Leah,
I'm Jamie.
and we are both from Spontaneous Construction. So today we'll be presenting to you a little bit about CAD and how to create 3D models. Starting off, what is CAD? So CAD stands for Computer Aided Design. It's a way that you can make 3D models and 3D parts online and eventually create them in the real world. It's used by many professional engineers and in many professions. So we're mainly going to be talking about OnShape, which I'll get more in detail into in a minute. But there are a range of basic to very advanced CAD programs, and some of which can even run simulations. So once you have a CAD, you have to create the 3D part. These are a few of the main ways to create parts. There's additive manufacturing and subtractive manufacturing. Additive manufacturing is something like 3D printing, where you start out with nothing, and then, at least in 3D printing, it builds up, putting plastic or metal or other materials like nylon down layer by layer, building up until you have the part. Then there's subtractive manufacturing. This is like laser cutting, where you have a sheet and you're able to cut parts out of the sheet, or CNC, where you've got more of like a cube of material, and then you cut away the excess material till you're left with your part. There's also lathing, which is another way to manufacture parts through subtractive manufacturing. So what are the pros and cons of creating CAD? It's pretty fast. You can make whatever you'd like to quickly and easily online. It's also very versatile. You can make whatever you'd like to. Pretty much whatever you can think of, you can make. And it's great for prototyping, because with CAD, there's a very clear difference between your iterations. Some of the cons of it, though, are the accessibility, especially when you're actually making the parts. It can be hard to find 3D printers, laser cutters, CNC machines if you don't have a set place already. And CAD can be a little confusing and complex when you're first learning it, but that's what we're here to help you with. So on that accessibility idea, where can you go to create 3D parts? So many schools and libraries have maker spaces where they will have 3D printers, maybe even laser cutters, and you can use those to create the parts you've designed. If you're in Minnesota, we also have a great 3D printing company called Stratasys, and they've offered their services to any first teams who would like to reach out to them. So 3D print parts for you if you just send them your design. You can also reach out to other teams. Some teams have 3D printers, and you can ask them. I'm sure they'd be happy to help you if you need a few parts. There are also like 3D printers you could buy. For example, there's some DIY 3D printers that you actually get to make yourself. So you can really see how it works before you start creating parts with it. So OnShape is the software that we're actually going to be showing you how to CAD with. So this is a cloud-based CADing software, and you can find it online. You can all go ahead and make your own accounts now. So it's free, easy to use. You don't even have to be affiliated with a team. So all accounts are free. It also allows you to share parts with other people who also have OnShape accounts. So it's really nice. You can let other team members edit or look at your designs when you need. You can also easily import parts. So if you need to compare a motor to the rest of your part, you can download that, which Jamie will show you how to actually import parts later, but you'll be able to put that into your CAD and compare it with your design. And OnShape is also a pretty easy one to use, especially at first. So it's a pretty beginner-friendly CAD program too. Some of the cons, though, there are some software programs that have better assembly functions. And as I was saying earlier, it is a little bit simpler, so that's nicer for beginners. But once you get to a higher level, there are some more complex ones that can run things like simulations, which is where you'll have multiple parts working together and you can actually make them move together as they would in the real world. So now we're going to get into the interactive part of the lesson, and Jamie's here is going to show you how to make a part.
Okay, so what we're going to be creating today is a mechanism wheel adapter for these Go Builder wheels here. What we're going to do first, it's also going to be a hex axle. So we're going to be creating that for this part you see here with the holes in there, and that's where we're going to be creating it. So the first thing we want to do is download the step file for this actual part. So a step file is a kind of a 3D rendering or model inside a file like this one. So you're going to open this on your computer, and we actually want to extract this file because it's going to be zipped here. So we want to get to the actual step file itself. So once that's done, you can see it actually has the step file inside of it. So pause the video if you need to download that, and just so after we have this downloaded here, we're going to go to OnShape. So as you can see here in the top left corner, there's this button with create on it. This is how we're going to actually create a document here, or our model area. So we'll click on create, then document, and name the part so you know what it is. And as you can see here, this is what OnShape actually looks like for the first time without any sketches or anything in it. So it includes many of these planes here, 3 planes, the front, top, and right planes. That's where you're going to be creating all your sketches on to later bring them to life or 3D into 3D. So how you actually maneuver around OnShape is by using right click. You can maneuver around here like this and see your part at different angles. There's also this cube here for helpful alignment with a certain plane like that. So the part we have that we're going to be making, we need to import it into this document so we can access it and know the dimensions for it, and so we can be able to create that part. So what we're going to go do here is go to the bottom left corner. On the bottom left corner, there's this plus sign. This is where you're going to be able to import parts actually. So we go plus sign, import. We're going to import the Go Build a mechanism wheel step file, which is again the 3D rendition of the actual part. And we're going to import to this document, press OK. And as you can see, it's going to download here, and it takes a bit for it to actually appear down at the bottom where you can see all the different areas. But once it's actually downloaded, here you'll see something pop up, CAD imports, and it's going to start generating the preview or the part itself. So we can actually work with that and make sure that we get all the dimensions that we need for the axle and the hex axle and the actual part that we're going to make onto those holes for the wheel. So we're just going to wait for it to load for a bit. If yours takes longer, you can pause the video and just wait for it to download. As you can see, a bunch of different parts pop up. These are the individual parts for this actual assembly. See like the little roller there, but the final assembly should be the left one here. And there you go. The part is downloaded into your OnShape, and this is what we're going to be working with here. So the first thing we're going to be doing is actually taking dimensions of this. So there's this measure tool down here, which is select entities to measure. So we're going to choose the width that we want for this actual part. So we're going to click on this point here. We're going to click on another point over here. So it's going to be around this actual holes here, so it won't be too small or too big. So the length of this is 1.235 inches, which is what we're going to be using later. So now we're going to go back into our part studio here. And then we're going to be working with sketches. So a sketch is a way for you to actually draw out the part that you want, the 2D part that you want. It will create that, and then later we'll be able to make that into a 3D part. But for now, it's just going to be 2D. So the first thing you do for a sketch is select the plane that you want to sketch on, whether that be one of the planes that they already may have for you, like the front right or top plane. So we're going to be using the front plane here. Also, it can be on parts, like a plane on a part or a flat surface there. So you can also create sketches there. So as you can see, there's a bunch of different tools here that you can actually use to create the parts. So there's like text, polygons, arcs, circles, rectangles. You can do it with center point or 3 points, and that's just different ways to actually make that specific shape. So what we're going to be doing here is using a center point circle. And remember the dimension that we had before, which was 1.235 inches. So we're just going to drag that out and a little box appears. You can actually start typing the dimensions that you want. This can be in any dimensions. We want inches. The default is inches. So if you just hit enter, it will automatically do inches, but you can also do millimeters, centimeters, and more. So we're just going to do inches here. And there you go. That's the sketch for the part that we want so far. So now we're going to approve the sketch here like this. And as you can see, it turns into this kind of shaded thing that we're going to use to create it 3D. So the way we make it actually 3D is with actually pause the video if you need to catch up here, because it's a lot to process in the first steps. So now onto the addition or additive properties for OnShape. So these are the tools you're going to be able to use. The main one is extrude, which just takes a sketch and extrudes it up, or whatever way you make it do it. That'll create the part into a 3D part. There's also things like revolve, sweep, loft, and more, which are just more complex if you're feeling creative. So you can click on extrude here, and then we'll click on the part we have here that we want to extrude. As you can see, it extrudes up like that. So we want it around 0.2 inches thick, because that's like the best thickness, I'd say, for a 3D part. If you're going to 3D print it, because it provides the best structural integrity. If you're doing it out of metal, which is also a good idea if you want these parts to last long, it would be less thickness, because metal doesn't need to be as thick, it's a lot stronger. So we're just going to do 0.2 inches for now. And when you hit enter, as you can see, it creates that 0.2 inches thick. And we'll hit approve here like that. And as you can see, the part is now a 3D model of what we're going to be creating. So there's also other functions that you can use to help you out in your process of creating parts. There's the refining tools here, which mainly involve Fillet and Chamfer. So Fillet takes an edge like this one, and actually, as you can see, it smoothens it out like that into a kind of semicircle, and you can make this bigger or smaller. 0.02 is pretty good for this kind of part. The functions of this are, so your parts are less sharp and you won't injure yourself if you're installing them. It also can be helpful for if it's a really thick part or long part on the base of it. Then on a 3D printer, if you have that little lip there, if it's sitting like this on the 3D printer, then it will be able to be scooped off the 3D printer much easier. So yeah, we're gonna just approve that for now. And that's what that looks like. There's also chamfer, which we can't actually do on this edge because it needs to be a square. But what it does, it just takes a rectangle, and it takes that and it kind of just creates that edge into a flatter, more triangular version instead of just just the sharp edge there. So it can smoothen it out without actually being round if you don't want it to be round like that. So we're not going to do that right now. And then finally, some other tools you can use are these duplication tools. There's this linear pattern one, which just creates a part into different, it duplicates it into different patterns like a curve or a square. But then there's also mirror here, which mirrors a part across a plane. So the part, we're going to select the part we want to mirror here. And then you select the plane that you want it to mirror across. And it just, see how it duplicates it like that. This is helpful for having two claws that you want to actually have duplicates of on both sides. But if you only make one, then you can just mirror it across and you'll have two that are mirrored across from each other, and you'll be able to create those claws much easier than caddying both of them at the same time. So that's one of the main functions for these duplication tools. So we're not actually going to do that right now. If you need to catch up, just make sure you pause the video. Yeah. Okay, so now we're going to move on to assemblies. So how you create an assembly is plus create assembly here, and that will actually create your assembly for the parts that we want to combine together so we know how to create the holes. So before we had, remember we had the wheel, so we can insert parts here, up here, the top left, that's how you insert parts here. So we're going to insert our part that we made so far. And then we're going to go to assemblies, because remember the part that was down here was actually an assembly. So we're going to click that here and just move it around here. So, and then once we confirm that, they'll both be inside the assembly. So what an assembly does is actually, it creates it. You can put parts into it and combine them together into one part. This is very helpful for things like robot CAD. If you want to CAD your entire robot in OnShape or other softwares, you can use this to see how everything will fit together and how to best use space. There's also creating parts that need to be combined together, like some sort of double-sided part or something like that. You'll be able to kind of fuse them together here in an assembly. So it can also be used for lining up parts for holes, which is what we're going to use this for. So how you're going to go about doing this is there's these things called mates. So the main mate things we're going to do to combine these mates together is Planar Mate or Fasten Mate are the main ones that people use. Planar Mate is probably more common because it's just for flat surfaces. Slider Mate and Revolute Mate are things where the mate will actually slide or rotate at that mate. So we're going to click on Planar Mate for now because ours is flat. And as you can see, all these little white dots appear. That's what an actual mate is. So when you click two white dots on different parts or on the same part, you can actually join those two mates together. So we're going to be selecting the middle of the part here. See how that little white dot pops up here. We're going to select this one first because the first one that you select moves. So we don't want to move this entire wheel because it's an assembly and it's not joined together. So you would only move this silver part right here, which we don't want. So what we're going to do is combine these two parts together using the mates now. So we'll position this right above where we want it to attach to. And once you do that, you can select Planar Mate, which is what we're going to use for these flat mates here. We'll select the middle mate here because we want to position this in the center because we want all those holes lining up. And then we'll select the middle mate of this one on the top of the wheel. And as you can see, it fixes onto the middle right like that, and you can confirm it there. So now once we have this part like this, we'll be able to go back into our part studio in something called editing in context. This creates a kind of ghost-like appearance of the wheel, but it creates this part solid so we can actually see the wheel holes and be able to line them up for creating those in our part. So if you right click on the part that you want to edit in context and then press edit in context, see how it brings it back into there and you can see the wheel like that. So now once we have that, we'll be able to actually create sketches of those holes. So if you need to pause the video and catch up, keep that in mind, you can do that. Okay, so we're going to go into sketch. And then we're going to actually select the part with the holes so we can draw on them much easier. And then we'll turn this around so we can see the holes here. And then we're going to sketch out all these holes here. And you can do this with me and use 3-point circle because that's the best way in order to select the outer edge and get it the most accurate. So I'm just going to go ahead and do all this. We'll use these holes for the screws where it will attach onto the actual Magnum wheel itself. And there you go. Once you have all those holes drawn out here like that in the sketch, we can confirm that. And as you can see, they're all drawn out here. And we'll take that sketch, select it, and then extrude it. Extrude, before we used it for solid things, but you can also use it for creating holes and stuff. So you'll go to remove here. And as you can see, it says it's red because it's not actually going through the part. When you do an extrude, you actually have to pull it through the part here like this. And there you go. It can see it created the holes like that. So we'll go ahead and confirm that sketch. And there you go. All the holes have been created for the screwing it into the Magnum wheel. So now the last step we need to do is create a hex axle hole here. So if you just look up the 5mm hex axle in Rev, we're going to download the step file for that. As you can see, it's downloaded here. So now we'll go back to our actual OnShape document. We'll go back into assembly because we want to insert this into here and make sure that they're combined so we know which way to position the hex axle in. So we're going to go insert part again. Or sorry, we have to import it first. So import it from our downloads. Forward to this document. And this one should be fast since it's such a small part. Yep. And as you can see, it pops up there. So we're going to go insert here. And then once we select it, as you can see, the hex axle comes out here. We'll confirm that. Like that. We're just going to position this above where we want it to attach to, right in the middle. So we'll go Planar Mate again, because it's just a flat surface. And then we'll select the bottom mate here in the top center mate of our Magnum wheel adapter. And as you can see, it puts it right onto that like that. So we can go ahead and solve that here. And now we are going to edit in context again so we can get the dimensions of the hex axle on our Magnum wheel adapter. So we'll go create a new context with that in it. And as you can see, now this is in here. And now we're going to create a drawing of that part or a sketch. So we'll go sketch here again. Pause the video if you need to catch up. Okay, so we'll select this plane here, the top of the actual axle, so we can better draw this out. And then we're going to go inscribe the polygon. And we'll select the center, and this drags out from the center. So since it doesn't actually let us select the outside edge here, we can just zoom in really close like this, and that should be plenty accurate enough for you to have the part or the sketch positioned perfectly. And as you can see, you can also create ones with more sides. We're just going to be doing with 6 right now, because that's what a hex axle is. And then we can go ahead and confirm that sketch here and extrude it. Once again, we're going to use remove. And once we bring it all the way through, we should create that. Oh, right. Since this is a actual separate part on top, we select this plane here we selected this plane to draw on, not the actual part itself. It's going to go red because they're not one part together. So we want to merge them together by pressing merge with all, and that should fix the problem and create the hole here. And now, as you can see, once we get rid of that, we have our finished Mechnamobile adapter. So that's all that we had for today. Thank you guys for watching so much, and hope you guys have a great experience with CAD and you can create many good parts in your robot.